All right, so continuing where we left off. Um, oh, okay. So, basically the observations was that for KCl, you were able to dissolve an extra 15 grams of KCl when the temperature went up from room temperature to 74.9 degrees centigrade. All right, so that was a change by 53 degrees centigrade. All right, and so an extra 15 grams of KCl was able to go into solution. So the official and experimental plots were identical. The intercept, which is when extending the line, the solubility corresponding to 0 degree centigrade was 29 grams of KCl per 100 ml. Now, the same thing for ammonium chloride. Again, solubility went up um, when you increased the amount of ammonium chloride from 40 to 60 grams, so an extra 20 grams. And the temperature increase was from 26 to 70.1, so 44 degrees centigrade. Again, the intercept also was identical, was 29 grams of ammonium chloride per 100 ml at 0 degrees centigrade. So we already have talked about all the plots and the data. We looked at the data. And the data and the graphs, they are showing that as temperature increased, so did the solubility. And the official and experimental values were identical. Therefore, the percentage error at 60 degrees centigrade was 0. And so these, because of the fact that the data points were exactly similar, then both the plots were kind of superimposed on each other in the graph. So the temperature dependence of ammonium chloride in 100 ml of water is identical to KCl in the sense that as temperature increased, so did the solubility of ammonium chloride. Okay. So what are some of the conclusions that you can draw between the experiments 1 and 2? Well, the solubility of both increased as the temperature increased in 100 ml of water. All right. And that shows there's a direct relationship between solubility and temperature, which did support my hypothesis. So, what are some real world examples? What can be learned from this concept of solubility? Most solid substances, whether they're sugar or salt, especially table salt, is able to dissolve better when the solvent is warm, all right, as opposed to a cold solvent. So when making sugar syrup, as you're warming the water, as you're heating up the water, you are able to dissolve more and more sugar into that same amount of water, resulting in a thicker syrup. If you were to take this thick syrup and put it into the refrigerator, you would see that all that excess sugar that you forced into solution crystallizes out. So it comes out in the form of crystals of sugar. All right. So this is a real world example of making syrups. And this process is also in the lab referred to as recrystallization. The reason for that is, suppose you took some impure substance, the substance that you were desired from your lab experiment, but you wanted to increase its purity, all right? So initially, the substance you procured from your experiment had other impurities in it. So what you could do is take a lot of it and dissolve it into a small amount of water, like 100 ml of water, okay? And then what you would do is a process called as seeding, that is putting a tiny little crystal of that substance, the desired substance, into this water solution, which is super saturated. There's too much of the solute in it, all right? And then as that solution starts cooling down, what will happen is that desired substance crystallizes out, all right, because there's an excessive amount of it, it comes out. And when it comes out, those crystals are very pure, all right? So this results in a very pure substance, um, devoid of all the old impurities, all right? Same principle is used during distillation, is when you boil and then evaporate the water and then cool it down and collect the water. That water, distilled water, is very pure. It doesn't have any dissolved impurities in it, right? So what's the significance of this? The pharma industry, the pharmaceutical industry, uses this recrystallization process all the time, all right? Especially to enhance the purity of their drugs, all right? So to get rid of any kind of harmful impurities, even when they're, for example, making aspirin or any other drug, all right? What they will do is use the method of recrystallization in order to enhance the purity of their desired compound or drug. Okay, so a lot of compounds are also prepared by the same method. Sometimes if you look at the labels, you might even see that it might state that it's recrystallized at certain temperature, or etc. So if you look at that food label closely, you might actually see something about um, that mentioned there. All right, okay. So these are some real world examples, and that's about all I have. You might want to look into it a little further to see if you can come up with other examples. Okay, and that's the end of this lab 13.